Let us continue our exercise 1.2. The next example or the next type is 3. Find the derivative of the inverse of the following function and also find their value at the point indicated against them. So you have to find the derivative of this function at the given point. So what is given? Y is equal to x raised to 5 plus 2x raised to 3 plus 3x. Differentiate this function with respect to x, we get dy by dx is equal to d by dx of this function. So d by dx of x raised to 5 is 5x raised to 4 plus d by dx of 2x cube, we can take 2 outside, and derivative of x cube is 3x square, so 3 into 2 is 6x square, and derivative of 3x is 3. Now we have the derivative of the inverse function dx upon dy is 1 upon dy by dx. So dx upon dy is 1 upon 5x raised to 4 plus 6x raised to 2 plus 3. But we want the derivative of the inverse function, and they have given the value at x is equal to 3. So we will put this x is equal to 3 in the given function. What you get? Y is equal to 1 raised to 5 plus 2 times 1 raised to 3 plus 3 times 1. 1 raised to 5 is 1, 1 raised to 3 is 1, 3 into 1 is 3. So 3 plus 2 plus 1 is 6. So whenever x is equal to 1, we get y is equal to 6. So we have to put here y is equal to 6. Derivative of this x with respect to y, when y is equal to 6, we get its derivative, reciprocal of the derivative of y with respect to x when x is equal to 1. So we'll put x is equal to 1 in this expression, and then we get the derivative of the inverse function at the given point, 1 upon 14. Similarly, the next function y is equal to e raised to x plus 3x plus 2 at x is equal to 0. Now y is equal to e raised to x plus 3x plus 2. Differentiate with respect to x. What we get? E raised to x plus 3, because derivative of 2 is 0. So dx upon dy is 1 upon dy by dx. Okay, so what we get? Dx upon dy is 1 upon e raised to x plus 3. Now again, whenever x is equal to 0, what is the value of y? The value of y is e raised to 0 plus 3 into 0 plus 2. E raised to 0 is 1, 3 into 0 is 0 plus 2. So 1 plus 2 is 3. So we will find the derivative of the inverse function at x is equal to y is equal to 3. Then the derivative of the reciprocal of the function y with respect to x at x is equal to 0. So e1 upon e raised to 0 plus 3, e raised to 0 is 1, 1 upon 1 plus 3 is 4. The next example is y is equal to 3x square plus 2 log of x cube. What is given? Y is equal to 3x square plus 2 times log of x cube. Now here I will use the property of the logarithm. Log of x cube can be written as 3 times log x. Okay, then after multiplication you get y is equal to 3x square plus 6 times log x, and then we will differentiate this function with respect to x. Derivative of the first function plus derivative of the second function. Derivative of 3x square is 6x, and derivative of 6 log x, 6 is constant, so we can take it as it is, and derivative of log x is 1 upon x. So 6 times x plus 1 upon x can be simplified as x square plus 1 upon x. So dx upon dy is 1 upon dy by dx. So using that formula, we get x upon 6 times x square plus 1. Now to find the derivative of the inverse function at the point x is equal to 1, we must have the derivative value of the inverse function when x is equal to 1. Now, so x is equal to 1, y is equal to 3 times 1 square plus 6 times log of 1. Log of 1 is 0. So 6 times 0 is 0. So what will remain? 3 times 1 is 3. So derivative of x with respect to y when y is equal to 3 is given or is obtained by putting the value of x is equal to 1 in the reciprocal of the derivative of y with respect to x. So put the value x is equal to 1 in this expression, you get the value as 1 upon 12. So this is the derivative of the given function. Given function or derivative of the inverse of the following function. Now the next function is y is equal to sine of x minus 2 plus x square. Differentiate directly with respect to x. Derivative of sine of x minus 2 plus d by dx of x square. So dy by dx is equal to cos of x minus 2 into d by dx of x minus 2 plus 2x, because here we have used the formula sin f of x. Derivative of sin f of x is cos f of x into f dash of x. Now d by dx of x minus 2, derivative of x minus derivative of 2. So we get cos of x minus 2 plus 2x is the derivative of y with respect to x. Now we want it derivative of the inverse function. So dx upon dy is obtained by taking the reciprocal of the derivative y of y with respect to x. Put the value. This is the derivative of the inverse function. But now they have asked to find the derivative of the inverse function at the particular point x is equal to 2 when y is equal to what? Y is equal to sine of 2 minus 2 plus 2 square. 2 minus 2 is 0, sine 0 is 0. So we get 4. So derivative of x with respect to y at y is equal to 4 is obtained by 1 upon dy by dx at x is equal to 2. So put the value of x is equal to 2 in the derivative obtained. We get cos 0 plus 4, but cos 0 is 1. So 1 upon 1 plus 4 is 5. F of x is x cube plus x minus 2. Then find f inverse at f inverse, derivative of f inverse at 0. It is something different from the previous one. F of x is given, so differentiate with respect to x, we get this derivative. Okay, so derivative of the given function is 3x square plus 1. So the derivative of the inverse function, we want to find derivative of the inverse function, not this function. Now what they have given the derivative of the inverse function at 0. That means y is given and not x. Okay, y is given and not x. In previous example we have given x and not y. So this is y is equal to 0. So we have to find the x. So we'll put this y here. Y is equal to, y means f of x is 0. So x cube plus x minus 2 is equal to 0. So this is the cubic polynomial. We can use synthetic division or to find the roots of the polynomial. So x is equal to 1 is the root of this equation, and other roots are complex roots. So we have not find out there here. So what we get, x is equal to 1. So I will put f inverse, its derivative at y is equal to 1 upon derivative of f of x. Okay, it is same as that. Okay, I will write here dx upon dy is equal to 1 upon dy by dx. I am writing the same thing but in the form of function, so don't confuse it. So put the values in this function, you get 1 upon f inverse at 0 is equal to 1 upon derivative of the f at x is equal to 1. So 1 upon 3 times 1 square plus 1 is 1 upon 3 plus 1 and is equal to 1 upon 4. So f inverse at 0, the value we got is 1 upon 4. Now using the derivative, prove that tan inverse of x plus cot inverse of x is equal to pi upon 2. Now that this is the property from the inverse trigonometric functions, and already we have proved there, but we have to prove here and using the derivative. So how to prove it? So let the function, let consider the left hand side as a one function. F of x is equal to tan inverse of x plus cot inverse of x. Call this as equation number 1. So differentiate this with respect to x, we get d by dx of f of x as d by dx of tan inverse of x plus cot inverse of x. So derivative of tan inverse of x is 1 upon 1 plus x square, and derivative of cot inverse of x is minus 1 upon 1 plus x square. Okay. So what will happen here? These two terms will cancel to each other and we get the derivative of the function as 0. But we know that if the derivative of the function is 0, then that function must be a constant function. So let that function be f of x is equal to c. So for any value of x, that f of x must be c only. So for any value of x, the function is c. So if instead of taking any value, I will take x is equal to 1 conveniently. So if you put x is equal to 1, so f of 1 is equal to tan inverse of 1 plus cot inverse of 1. But tan inverse of 1 is pi by 4 because tan pi by 4 is 1. And cot inverse of 1 is also pi by 4 because cot pi by 4 is 1. So pi by 4 plus pi by 4 is 2 pi by 4. It's nothing but pi by 2. So we get the value of c as pi by 2. Value of c is pi by 2. That means value of f of x is pi by 2 for any x. So hence we write this expression as tan inverse of x plus cot inverse of x is equal to pi by 2. Hence the proof. Now similarly we have to prove sec inverse of x plus cosec inverse of x is pi by 2. Now as already we have put it in the trigonometric function, properties of the inverse trigonometric function. Here also I will take this full left hand side as f of x and differentiate with respect to x. They will cancel to each other and I get f dash of x is 0. That means f of x is a constant function. So its value is c for any value of x. So now here I will take x is equal to 2. Okay. So f of not 1, here f of 2. F of 2. Sec inverse of 2 plus cosec inverse of 2. But sec inverse of 2 is pi by 3 and cosec inverse of 2 is pi by 6. Add these two. 30 degree and 60 degree is 90 degree. So pi by 2. So f of x is pi by 2. So here f of x is pi by 2. So from equation 1, we can write sec inverse of x plus cosec inverse of x is equal to pi by 2. Now we will end our session here and we will continue this same exercise in our next lecture.